Howdy everybody in YouTube land. Well, we're back on the Pioneer 8800 again. So I went ahead and did all the capacitors on this board. I did the 4 that were right here, and I wanted to stop and take a note of something. When I was getting ready to put it back together, well, while I was recapping, I was getting ready to spray these out and then put it back together, but I noticed that these stakes are heavily corroded, so I unsoldered them and cut them out of there, and I'm going to solder these direct to the board. This is because the rodents use this friggin' thing as a toilet, so it's pretty bad in here. And these caps were actually leaking pretty badly too. I haven't seen hardly any leakage except for the capacitors that are right next to something that gets hot, like over here. But these two were leaking pretty heavily, and that's probably why on this board you can see some corrosion there. And it also smells like rat feces too, so that's probably what corroded these. And this is your main audio path input, so it definitely has to be a clean connection or you're going to get a lot of noise. I cut these big stakes off too, so they can be soldered on directly. So we're going to go ahead and take care of that. I'm going to visibly check any of these other wire wrap stakes for corrosion, and if I see any, I'm cutting it out and I'm soldering direct because I don't need the intermittent connections. Then I'm going to get back to spraying this. I've already resoldered this potentiometer, so I'm going to spray all these pots and switches out, double check to make sure I don't have any more capacitors left on this board. I have to recap while I have an opening here because this was a pain to get out. I had to loosen all the other boards. So once I have that done, I'm going to move on, and we're going to go to this top board and start recapping it. And then we're going to get to this board, start recapping that board. Plus there's a transistor that needs replaced too, because look how burnt that thing is. It's pretty good. It's seen some better days. So I'm going to finish this up and then we're going to move on. So this board's done. That was a pain. I went ahead and sprayed out these controls and worked them back and forth a little bit. Same thing here. Went ahead and worked that back and forth a little bit. Caps are on there. Went ahead and, even though this is fairly worn out, as you can tell, I went ahead and got the caps on there too. Now while I was recapping this thing, I made a really dumb move. This thing fell down in here like this or something like that. And I saw a spark right here, and I'm thinking, whoa, wait a minute now. This thing hasn't been plugged in since I've owned it, and I've had it for a few months now. So come to find out, this capacitor here still had about a 30-volt charge left in it. I'm thinking, wait a minute, I just pulled these boards out, I just recapped this thing, and I've been working with this thing while half the rail has a charge. I'm like, you gotta be kidding me. And then why didn't I check the capacitors to see if they had a charge? Well, I didn't think to, because it's been sitting unplugged for a couple of months now. So even as seasoned as I am working on this stuff, I still make stupid mistakes like that. But, oh well, is what it is. You live and learn. And sometimes you don't learn and you keep living. So I discharged this cap. This was the only cap that was holding the charge. The other 3 were not. So I went ahead and discharged it. I used this little, there's a vacuum tube by over here, an old Compactron. I used the filament of this tube to discharge the, yeah. Anyways, so now I got all the caps in. There's a few discrepancies. For example, I've got this one, which is 100 microfarad at 25 volt, which I'm pretty sure I know where that went. I put a 16 in there instead. A 16 came out, and I had some 16s on hand, but I bought a 25. It might have been the next size up because of parts availability issue or something. I don't know. But this one is a 47 or 470 at 16, and I don't know where it goes. So how that got in there, I don't honestly know. There's 2 of them. I used one. It went here, but I don't know where the second one goes. So unless I missed one somewhere, Yeah, that's weird. I do not know. But what I do know is I have an extra one of those left over. Oh, the other thing I did too is I had 22 microfarads at 25 or 35 volt that I used, but I was too short. But I also had 22 microfarads at 50 volt, and I have no place to put those anywhere in here. So, but I was too short over here, so I just put them over here. So for some reason, the cap list has two less of the 4735, and a couple of 47 or 22 at 50s. So there might have been a revision to this design where somewhere in here had a pair of 22s at 50s. In this case, had a pair of 22s at 35, which is bone stock. There hasn't been any solder work done on this thing. So I just put them where I had them left over. So yeah, we'll see. Next thing to do is to get this stuff, the shield back on here, get that mounted in and get it powered up. Okay, screws are in. Power cord's plugged in. I do not have a dim bulb tester, which is a really, really bad idea. But this amplifier was semi-working when I got it. It was just very noisy. So, as long as I didn't make any mistakes, in theory, as soon as I flip that switch, this thing should power on. Okay, I'm not editing the video as far as cutting this out, and I haven't turned this on yet. I'm afraid to flip this switch. Really afraid to flip the switch, but got the camera rolling. We might as well do a first power up. I'm going to move the camera to above the unit in case there's an explosion factor. I can figure out where it came from. So, here we go. Whoa. Hey, no explosion. What do you know? That VFD, even though it looks really bright on camera, is super dim. Oh, it's bad, man. It's really dim. I mean, it works. I can see it. It's visible, but it's really dim. So I might have to do something with that. I've got some stuff on the way. That'll be a different video, but I have a thought process on what I want to do about that. And that is basically, you can't get these anymore, obviously, unless it's from a parts unit, which nobody's going to be parting one of these out unless there's no choice but to part it out, and it's probably going to be equally as bad. So the likelihood of getting one of these in decent shape is almost slim to none. So what I have is I've got a dot matrix, a 128 by 32 pixel dot matrix that I just ordered from Noritake, which is a vacuum fluorescent display manufacturer. So my thought process, it's not exactly the same. It's a little bit shorter. It only comes out to about here. But my thought process is to put a dot matrix display in here and then sort of emulate this one. Basically draw out the graphics like this in a microcontroller that'll be on the board above and make it look like it would be something that was designed for this. So I'd have the input selector, you know, I'd have the input selector to, yeah, that's not good. Now, I did spray this pot out. That's, wow. Yeah, I'm going to have to do a little bit more work with this because it tripped the protection relay. Anyways, I'll worry about that later. So I have the display coming, so I can engineer a solution for this. So it's still a vacuum fluorescent display. It still gives it that character because, sure, I could probably do a screen printed overlay that looks exactly like this, have a graphics designer make an exact copy of this, and say an overlay 3D print a light pipe and use LEDs. Sure, I could do that, but that ruins the whole charismatic, you know, the vibe of this thing, because this is a fluoroscan unit by Pioneer. Fluoro meaning vacuum fluorescent display. So this is part of the character of this whole machine anyway. So I have to come up with a solution for that, and it's got to be a vacuum fluorescent display. Obviously, it won't be identical to this, but I think I could recreate this layout in a bitmap format and then draw it on a dot matrix display. So obviously it won't look the same, but it'll look very similar. And then hopefully I have enough room to draw these characters on the display. So we'll see. I'm probably going to do that. Maybe not. I mean, it's still fairly bright. It's dim, but it's bright enough, I should say. But it's only going to continue to degrade. And I'm sure there's owners out here of these machines that have these displays that are completely dead or almost dead, and they're going to need a solution. Well, that's the next best thing. The Noritake dot matrix module is relatively available. So I have to see if I can fit in here. I might have to make a new metal enclosure to hold it, because the board's probably taller than this, but we'll see. I'll figure it out when we get there. Meanwhile, we got some more work to do, because if I change the pot, you can see that everything shoots on the screen. So we got to figure that out. Okay, so I have the speaker hooked up so I can figure out what's going on over here. Oh. Yep. That control still needs cleaned. But that's filter home. But here's the funny thing about that. This filter home is adjustable by the volume control. So that means the power supply for the preamp stage must be isolated from the power supply for the power output stage. So that tells me that the preamp stage, tone stage, has bad filter capacitors, which is probably 2 of these 4. So, damn it. Oh well. I was trying to avoid, because my meter cannot read these big caps. They're just too big. And I was hoping that I didn't have to replace those, because they're very expensive. You can't even buy that style anymore. You have to modify it. Well, it looks like I got to replace them. So, yep, that's a shame. Alright, well, I think what I want to do next is I'm going to flip this over, and I'm going to measure AC voltage on these caps, because the capacitors that are not filtering properly will have a little bit of ripple on it, which will be detected in AC voltage mode. So I've got a scope meter, but I don't feel like pulling it out. I'm going to check that real quick and confirm my suspicions that I'm going to need to order some capacitors for this thing. So that will railroad this for a part 3 video. Man, this thing's getting drug out. Well, let me go ahead and check that real quick, and then we will conclude this video. So, I was screwing around, checking tone inputs, and seeing if it changed anything with sound. It's kind of in and out. It wants to oscillate. So, the fact that it wants to oscillate made me want to check something, because the stability of the amplifier is directly related from voltage rails or something like that. So maybe I made a mistake. So before I flip this thing over, I was feeling back here for anything excessively hot. This voltage regulator that I replaced was warm. This one up here was ice cold. So I'm like, okay, well, let's go ahead. Let's check this one right here, the warm one. 52 volts. All right. Let's check the one next to that. Look at that. Let's see. 50 volts on that one. Negative. Positive on that one. So we have rail voltage going into both of those. But yet this one is ice cold. And that one's hot. So that might be where I need to look next. So I'm going to flip this over because I need to get to the other pins to see if there's a load on that transistor, just to make sure, because there could be a resistor open under here or something. I will need to go on the bottom and make sure that because that should be putting out around 32 volts, I think, plus minus 32 volts. So I need to verify that. All right, here we go. Power on. Let's check this one. Let's see. 30 volts, as I suspected. Let's check this one. 50. That's not right. Yeah, that's 50 volts all the way around, so this thing's not doing anything. All right, there we go. That would do it. So time to take a look at the schematic and figure out what we got going on here. And, you know, I'm starting to suspect that it's probably the 2SK34 that's bad. This transistor is not going into conduction, and I'm getting 50 volts out on a 32 volt rail. So that means that's my negative rail. So I got a positive 32 volts and I got a negative 32 volts. Well, that's giving me a negative 50 volts. So guess what? That's going to create an imbalance. And that's why I'm getting this hum and all this weirdness going on. That explains that. So I will have to investigate that further. So I went ahead and replaced the 2SK34 with this diode right here, which is the recommended modern replacement. And that is I called it a 2SK34, but it's a 954E202. 100 volt 2 milliamp current regulator. This is what everybody recommends to use on the audio forums, so that's what I went with. Didn't make a difference. So I'm sitting here, you know, trying to figure this out. I pulled this transistor out, made sure that it was not in backwards and it was still good. It was. I pulled this one back out and I checked it. It's also still good. I didn't hurt anything there. So I'm thinking, like, what in the world? So there's a resistor, a 22K resistor that goes right here, and as you can see it, I removed it. I tested it in circuit, and it was a little high, but not concerned. So it had me chasing my tail for a while. See, because look. See that? It's close. It's a little high, but it's close. I figured, you know, it's still a little high, and it's suspect. I mean, there's nothing else in this circuit that can cause this problem. So I figured, okay, let me pull that out real quick, which is, here it is right here. I tested the resistor with the multimeter, which I can't do because I'm holding the camera, but I tested this, and it's open. This resistor is 100% open. This tests very similar to the other three, so this is probably good. But I'm going to go ahead and leave this out temporarily to make sure this works as intended. And if it does work as intended, I'm just going to go ahead and change all three of them because these are notorious for going bad anyways. But yeah, there's a 22K ohm resistor that's open. Well, let's take a look to see what that looks like in the circuit. It's this guy right here. This resistor right here is open with the R2822K, which this is I'm not sure exactly what it does in the circuit, but what I can tell is it biases the base because there's a resistor here, which I need to test it, and then there's a resistor here that biases the base. So now this resistor's open, so that means all of this 32 volts right here is getting dumped straight into this transistor as it is. So unfortunately, that's probably why the transistor is turned all the way on and why I'm getting 50 volts instead of negative 32. So let's get that resistor replaced and then we'll see what happens. Okay, I got the new resistor soldered in. I went ahead and laughed that in. So now I guess, well, another smoke test. Let's measure this. Negative 33 volts. Oh, and the hum is gone. There you go. That's what it was. And my voltage was within spec, so I'm just going to go ahead and put this in correctly. And then leave that out, get rid of it. But there you go. That right there was the cause. That's probably why this amplifier was gotten rid of, because this was most likely bad before. But like I said, I was reading 30K in a circuit. So just goes to show you, rule of thumb, when it comes to resistors, you always want to check them out of circuit, because this was in parallel or series with some other components around here, and it gave me a false reading in circuit. So I pulled it out, and sure enough, it was open. Now I just got to go through. What I'm going to do is go through and check all my other voltages against the schematic and make sure everything is kosher. And then most likely just go ahead and replace the remaining 3 of those things, and then we'll worry about that. So I went ahead and removed the remainder of the 2 SK34s, and I went ahead and replaced them, all 4 of them, with the proper diodes. The diode that I had tacked in here I moved to the other side, so that has been replaced. Resoldered the filter capacitors where the electrical connections are. These are just support terminals. These 2 are electrical. So that's done now. The only thing really to do at this point forward is check the bias, check the offset, and all those little things just to make sure they're within spec. They should be. I didn't change any of the semiconductors on the amp board, and the reason for that is I was doing some research, and this is what Pioneer called a non-switching amplifier, which for some reason to me just sets off that little bug in my mind, being a cynical person that I am, that it's just a marketing gimmick. There might be some truth to it, but the reality is technically all Class AB amplifiers are technically non-switching in today's context if you refer to Class D audio. So I'm not sure in what context they meant by non-switching. I'm not entirely certain on that, but regardless, that also means the one side effect of that is the driver transistors that are used to run these outputs need to be super high speed bandwidth, so like 100 megahertz or higher. Well, it's becoming more and more impossible to find transistors that are in the TO220 package that are more than, say, 10 megahertz, 20 megahertz, which is not enough for the amplifier to function properly. So, from what I've seen online, so I just left it be. But it does raise a question. Let's say if you run into one of these that, for some reason, one of the channels got liquidated, so the power transistors are shorted, and you got to replace those, and you're not going to find this style anymore. And then that means you got to change the drivers too. Let's say one of the drivers got damaged. What are you going to do? How are you going to fix that design? And even if you did, now it's not going to match this channel because the parts are not even close to the same. So you'd have to match both channels up. It would be a nightmare to try to fix this thing if it ever got blown. So yeah, that's a discussion for another time. So anyways, at this point, I need to check all of that. And before I do, I'm going to hook up speakers, and I want to run this up to full temperature and then go check to the service information and see how close the settings are, because the other issue is the potentiometers these use are known for causing problems when you try to adjust them. So if the specs are close enough for government work, I'm just going to leave it alone. And at that time, we need to put it together. One thing I did notice, after I fixed that bad resistor, the noise from the volume pot went away. All the noise went away, which, looking back, makes sense because of the rails being offset, imbalanced. It probably had a DC voltage sitting on that volume pot. So that was like, because I noticed it was trying to oscillate and do all that thing, which was unusual, because my first thought was a bad filter capacitor, thinking, okay, I got filter hum. Not so fast. My rail had an imbalance, and that threw everything off. So that's fixed. All that went away. Now I got all 4 2SK34s replaced, so they're not going to be a trouble anymore. They're replaced with regular 100 volt 2 milliamp diodes. I got that resistor replaced, so now it's time to turn this on and make sure she's still stable, and it looks like it is. Do we have a LED? No, it looks like the bulb is blown for the power indicator, so I'm going to have to fix that. But I heard a click. So, well, I guess now it's time to hook up speakers, let this thing warm up, and then check all of my settings against the service information. So I'm sitting here listening to music, which I had to pause it so I don't get a copyright strike. But I was listening to music to warm this thing up, and she's getting pretty hot now. So I've been running it pretty close to full power, and those little speakers are just barely handling it. Anyways, so while I was sitting here, I was looking at it to figure out why the indicator lamp wasn't working right, and I'm thinking, where in the world's the wire? So then I pull this out, and someone had cut the wires off, and then I saw that shoved down in there. So I'm thinking, what in Sam Hill was someone thinking? That better not be shorted together. So I'm going to say that are the lamp wires, because it doesn't have an LED in it, which makes sense because LEDs really weren't quite bright enough yet when this came out. So I need to figure out what bulb this is. I think this is just a standard old 8-volt bulb, nothing special, and then just get that replaced. For now, I think the quick, easy, dirty thing to do, since this has been running for a bit, is to go ahead and measure the DC offset from the output terminals to see where we are. Not bad. I don't see any. So this thing is still... That's a little high. I'm going to have to adjust it. You want to get this as close to 0 as possible, so I will have to adjust that channel a little bit. Not a big deal. But these are the potentiometers that I was talking about. So, also, to reiterate on the their Class AB and the non-switching amplifier thing. So, I'm trying to think of why they would... I'd say if I studied the material, I could figure that out, but I don't know why they would have said non-switching amplifier, considering, of course, I'm thinking of context of right now, here and now, today in 2020. When you say non-switching amplifier, to me that means anything that's not a Class D, because Class D is a pulse width modulated switching amplifier. Class AB activates in the linear region. There is no switching. It's just all... You operate in the active region of your complementary power transistors and even all the other transistors. So the only other thing that I could think of is Class GH, where your output transistors are switched in and out depending on the volume of the audio or the amplitude, or there's a pair of transistors that's used to regulate the rail voltage, and it follows just above the output transistors. So the output transistors are not running as heavy, but it's still operating in the active region, the linear region of the power transistor. So I'm not entirely certain what they refer to that. So every time I hear something like non-switching amplifier, my cynical marketing gimmick spidey senses start tingling, like, oh God, So anyways, there could be something to it. I don't personally know. Maybe someone else does. So, next thing I'm going to do is I'm going to go ahead and just get the output offsets adjusted and get all that done. And then I got to get a bulb ordered in for this. Then we can start to put this thing together. So that is going to be it for this series, part 2. And we are going to get the bulb in and all that stuff, and we'll put this thing back together and have a sound test for part 3. And that should wrap up this project, I'm hoping. Thank you for watching, and if you have a comment, please feel free to leave one.